The Apix MS is used to monitor the very high purity gases that are used in semiconductor production. So gases that are used either as purging or annealing gases in wafer production. Just a few molecules of moisture or oxygen in those gases can destroy microchips, render them useless, and cost thousands, perhaps millions of pounds worth of lost production. So in that instance, that type of mass spectrometer is monitoring the purity of the gases down to parts per trillion. So literally, it will see one molecule of moisture or oxygen in a trillion molecules of a base gas, such as nitrogen or hydrogen. API mass spectrometry is in the name. It's atmospheric pressure ionization. It uses a high voltage discharge from a needle, produces a corona discharge, and it happens at atmospheric pressure. That's advantageous from a sampling perspective because we just take high purity gas directly to the analyzer without any preconditioning. Fortunately for monitoring of very high purity gases in the semiconductor industry, the impurities tend to have lower ionization potential than the pure gases. So we get lots of charge transfer occurring between pure gases such as hydrogen, nitrogen, helium to the impurities that are of risk to the semiconductor wafer manufacturing. All our Apix models use the same analyzer. The difference is that with a Delta Q, we have a single analyzer in a cabinet with a facility to measure from multiple sample streams. So effectively a multiplexing one analyzer to several sample streams. With the Quattro, we have 4 independent API mass spectrometers in a single cabinet, and that allows the user to sample simultaneously from their 4 bulk gases. That's 4 independent API mass spectrometers in a cabinet, but they share some of the infrastructure. So the system for blending down calibration gases used with APIMS is quite complex, and it's actually quite expensive to build. So users of the Quattro can benefit from having only a single gas blending system which is shared between 4 analyzers. So their total cost of ownership then is much lower than that of buying 4 individual Apix DQ systems. All those systems can monitor multiple streams. So with an Apix DQ, you can monitor up to 8 sample streams. That's sequentially. With the Quattro, you can have up to 16 sample streams, and you have effectively a sequential measurement from any 4 of them at one time. Another advantage of the Apix mass spec is that we can essentially change the conditions within the ionization region according to each bulk gas and each target impurity. So in real time, as we measure different impurities, the software of the mass spec will be changing the conditions of the ion source to optimize ionization and charge transfer between the bulk gas and each of the target molecules. It also then, when you switch between different bulk gases, say nitrogen to hydrogen, it will then change the ionization conditions to optimize charge transfer from hydrogen to the target molecules, or indeed proton transfer, because we use a system called proton affinity with hydrogen, and that's all done through software. It's not user controlled, it doesn't require any user intervention, and it all happens within a few seconds of the complete analysis of the bulk gas by APIMS.